right, on this first one, remember that we always want to go by angles are probably the easiest, or look for markings. Very rarely will you have to do a lot of calculating. You just have to identify, right? So we know that these two sides are the same length. Therefore, if there's a 42 across from this side, then the one across the other will also be 42, right? So I would give you a mark for that. If you identified that fact, I'd say you get a mark, right? Now we need to find M, right? So angle M is simply 180 minus 2 times 42. Or if you went minus 42 minus 42, that's all good, okay? So M is equal to, so that'd be 84, right? So we're at 96 degrees. So you get a mark for that, for the correct answer there. So for question 1A, it's 2 marks. So give yourself a mark out of 2 for 1A. Now it's saying classify triangle MNP by angle measure and by side length. Now I don't care which order you do this in. I honestly don't. Okay. By angle measure, we know that this one is an obtuse, right? So we would say obtuse because it's greater than 90. So you get 1 mark for this piece. If it's somewhere on there, you get the mark. If you put down acute, you don't get the mark. And by side length, it's already kind of a giveaway, but by side length, this will be an isosceles. Okay, so we get another mark there. So if those two things are on there, you get the 2 marks. So 1 is out of 4, okay? Question 1 is out of 4, so give yourself a mark out of 4 for 1. So A is 2, B is 2. Classify each of the following triangles by angle measure and side length. So here I'm wondering to see what this is. So I'm going to call this angle X, right? Angle X would be 180 minus 52 minus 38. So that gives me 90. So this would be a 90-degree angle. Okay. So this one right here, first of all, it's a right triangle, and because all angles are different in measure, I know that all sides will be different. So this is a scalene triangle. So this is how this goes. You get half for this step, you get half for this, and you get half for that. You get 1.5 for 2A. Okay. For B, I kind of made the marking disappear, but you should have seen these 2 markings. So that allows you to find this angle, right? Because these two will be the same also. So we're going to go, if we wanted to call this X, right? Angle X would be 180 minus 150, and all of that divided by 2, right? Because you're splitting the remainder in half. So that'd be 30 divided by 2, which is 15 degrees. So we know that this is 15 here, and this is 15 as well. Okay, so we have obtuse, that'd be half a mark, and we have isosceles, half mark as well, and you get half a mark for calculating that 15-degree angle. If you didn't calculate this and you just guessed, you lose the half mark here for calculating, okay, for not calculating. So you just get 1 out of 1.5. And then this one, anybody use cosine law to figure this out? If you use cosine law, because this is an SAS, you actually find that this is 5.5 centimeters. So right there, you can tell this is an equilateral triangle. So if you did that, you get 1.5 bar none. Like you get 1.5. If you use cosine law, you get 1.5. If you just put down equilateral, I'll just give you half a mark, okay? Because what you should have recognized is you don't use cosine law if you don't have to, right? These two are the same, right? Therefore, their angles are also going to be the same. Like these two are going to be equal to each other. So if we call this x, angle x is going to be 180 minus 60 divided by 2, which is 120 divided by 2, which is 60 degrees. So now you found that this is 60 here, and this is 60 also, so it's equilateral. So you have to have some sort of work attached to it. So I'd say 1 for the work, whether it be cosine law or whatever, and just half a mark for the name. So that's where the 1.5 for each comes from. Why does it say out of 15? I believe that the backside probably never made it to this AC. Or is there a backside on yours? Okay. Okay, then never mind, we're good. So let's just tally up so far. What do we have? We have 4.5 and 4, the first one, right? The first question is out of 4. So 4.5 and 4, so it's out of 8.5 so far. Okay, so maybe just question 1, put a mark out of 4. Question 2, put a mark out of 4.5. So you know later on when you're adding it up what it is. Okay, backside. Solve for length of side x. This should take you back to sine law, right? So sine of 90. I have my key there somewhere, but I'm just gonna 2.8, and this is sine of 27 out of over x. And so I have a lot of students on the test say this, okay? They set this up and they say x is equal to this, and then it's equal to, they have just a bunch of equals there. That's actually incorrect. So if you wonder what the notation error is, these two are equal to each other, and this whole thing translates to x, right? And then you show me that it's the same thing as multiplying and dividing these. Okay, that's what that is. 2.8 times sine of 27, that's 1.27 centimeters. So I would give you get 1.5 if you get the right answer, okay? If you get the right answer, you get 1.5, provided you've shown some work. If you forget your units, take off half a mark. Here, we have a pair there. And in order to get the angle across from it, we just go, all right, 180 minus 90 minus 49. So this angle right here would be 41. Yes, that's 41. So if that shows up, give yourself half a mark. And then we go sine of 49 over 20.2 is equal to sine of 41 over x. And I will skip the work, okay? Because you should know at this point how to do it. That's 17.56 millimeters. So if you have the right answer and the work, you get 1.5 on there too. Here, the only thing you could use is Pythagoras, right? X squared is 78.5. No. I'm missing a leg, right? So I know I'm going to have to go hypotenuse squared minus the other leg squared, right? And then x will be square root of the answer. That's 1883.84. Square root that. That's 43.40 feet. 1.5 as well if you get the right answer. So the 4.5 earlier and the 4.5 now add up to 9, plus the 4 is 13. Again, if you forget units, take off half. If you round it incorrectly, take off half. Don't be gracious now, okay? Now you want to make sure you feel the pain. All right, what is the area of y, x, z? So making sure that some of you are awake, right? So you need to find the height first. So this would be worth 1 mark. This would split into 25. This is 45. So the height here is square root of 45 squared minus 25 squared. That's square root of 1400 exactly, which is 37.4166 meters. So I give you 1 mark there for that. And then the area is base of the triangle times the height divided by 2. And that is 935.42 square meters. It's worth another mark. So add it up out of 15, and I will make this available online that you can upload it. So upload it right away. Out of 15, okay? And if you're here, if you could also take a snapshot of it and submit it on Google Classroom. And then I have everything in one spot and I don't need to look for it everywhere. And then, question. And then just leave it on your desk later, okay? Okay, that's normally when you're continuing to use it, you do double the decimals. So I would just leave it for now, but next time, okay? Yeah. Yeah. Don't leave it blank, okay? Like you put a mark down, whatever you feel it should be, and then I look it over. Most of the time I agree with you. If there's half a mark variance, I leave it. I don't change it. Most of you are getting pretty good at, marking your own work. The province is big on self-assessment. So let's take a moment to upload it. So if I don't get it from you, like let's say today you're not uploading it, I'm just putting down zeros, okay? I don't have time to chase folks around. So unless sometimes there's a glitch, right? I understand that. But at this point, you should be pretty good at submitting work, okay? Doing it the right way. Thank you, those of you that use the Adobe for the test. It's a lot easier for me to go from one page to the other. It's just one file. Even if you later on get your test back and if you want to look through it, it's a lot easier to just go through the pages, right? Instead of opening each individual edited file if you go back to your test, I don't know if you're aware of this, but if I return it to you, there's the original file and then there's the edited file, which has my markings on it. Like there's a red pen that actually mark things, okay? And so the edited files have my markings and then the originals are yours. I don't know what it looks like on your end. I'm guessing it's the same as what I see when I mark it on my iPad. All right, keep submitting. And we're going to go to page 190. 190 is completely blank, okay? Should be nothing on page 190 in your booklets. Now, I will tell you this, okay, disclaimer. This chart here, I just made this up, but it is based on, if you come through my class this week and you look at the rack that's in the middle, you will see this yellow handout, which is not a formula sheet. So don't think, oh yeah, I've got that one. I should probably have picked a different color, I know. But we only have 4 colors to choose from, and yellow is the one that sticks out the most. And it basically tells you the properties of all the shapes that we're going to look at. But it's a little messy. It's not organized, I think, but it's straight from the province. So if you want it firsthand, you get it from the yellow sheet that you're going to pick up this week or you already have. So as soon as you're done, go to page 190. If you're here, please leave your AC behind on your desk before you leave, and then I know which ones to sanitize too. So it's like a 2-in-1. I don't need to come and burst your bubble. And we can just stay away from each other. It sounds sad, but that's what we need to do. And you will notice that if you come in here, I spread things out a bit more. I try to, so to keep things as safe as possible. And if your desks are ever, they look dirty, like they're kind of sticky, it's because we soak them at the end of the day and just let it dry. Because apparently that is the best way to kill the virus, to just let it sit. And so it may look like it's dirty, but it's actually very, very disinfected. Okay. Properties of quads. I call them quads, quadrilaterals, 4-sided polygons. So it's, if you think of quadrilaterals, think of your regular square, rectangle, all of those shapes. They all have 4 sides. So I kind of bunched them up, but this is true for all of these, okay? So I'm going to start with what's true for all of them. Sum of interior angles is always going to be 360. For a triangle, it's always 180. For a quadrilateral, it's always 360 degrees. So if you know 3 angles, you can find the 4th one. Triangles, you need to know 2, you can find a 3rd. Right? So this same idea applies here. So the first shape, and I bunched them up, okay? They're cousins. Parallelogram. Okay, sometimes we also just use this. Parallel, this is the symbol for parallel line, so parallelogram, okay? And this is what it looks like. right? And then we have a rectangle, which is basically the same thing as a parallelogram, but it's standing upright. Okay. If you have different colors, it will come in handy here. At least 2 different colors. The first thing that's true about parallelograms is that opposite angles are equal. So what do I mean by that? This angle right here is the same thing as the opposite to it over here. Okay? This angle over here, we're going to make 2 of these, is the same thing as the angle over here. That's what I mean by opposite angles are equal. They have 2 pairs of parallel lines, or sides, I should say. I'll call that sides. Same thing, but 2 pairs of parallel sides. Two pairs of equal angles. Hold on. Yeah, that's true, but why do I? That's already summarized, of equal sides. The equal angles are also true. That's stated by the point up there. Exception, a rectangle. So this is where they differ. So all these things are the same, but then diagonals, they split in half, but are not equal in length. Exception, rectangle, I'll maybe say that. Equal length. So the bisecting part is always true, but the being equal in length is not true. Okay. So one thing that I wanted to add about rectangle that I'm not going to state here is opposite angles are still the same. Watch. This one is 90, which is the same as this one over here. This one is 90, which is the same thing as over here. So that's still true, except for they're actually all the same, right? So I'll say that for right angles. That's true for just a rectangle, okay? This diagonal part here, I'm going to clarify. I don't want to make this diagram too messy, so let's make a quick parallelogram here. Right, so First of all, two pairs of parallel sides. What does that mean? This side right here is going to be parallel to this side right here. So this is the symbol that tells you that these guys run alongside each other and they will never touch. They will never connect. And the same thing with this. This side over here is parallel to this side over here. So two pairs of parallel sides is there. Two pairs of equal sides, right? This side and this side is the same. This side and that side is the same length as well. But now the diagonals. This is the diagonal part. I'm going to use a ruler to not mess this up. So diagonals go from one end to the other, from one, like on opposite corners, right? So this would be a diagonal there, and you have another diagonal here. And just use common sense sometimes. You can tell there's a long diagonal and then there's a short diagonal. Would you agree with me, right? This one here would be shorter than this one here because it's going, right? If it's a flat shape, like it's going all the way across. So this one is longer than that one, okay? What is true though about them is they split each other in half. So this stretch from here to here would be the same as this stretch from here to there. And coming along the shorter diagonal, this stretch over here would be the same length as this stretch over there. For a rectangle, like this guy right here, all four would be the same because you're actually talking about two diagonals that are the same length, but this is a parallelogram. Okay? So keep that in mind. I think these markings we can do here as well, right? That this is parallel to that, and this is parallel to this. That is true always. So you're not just wondering why is it only on this one but not on this one, right? That won't make the diagram too busy. But I'll tell you something. The province has asked, for example, draw a parallelogram, making sure you label at least two things that make it unique. You need to have markings on there. So like the angles would be one property, and then the parallel lines would be another property. If you wanted to make sure that this is the same length as that one, you make a mark like this, and two marks and two marks. So you're talking about length, right? And stuff like that. Okay, enough of these. So I make a line here, right underneath it. And this is going to be the square and the rhombus. So we're going to do rhombus first. Rhombus, think of it as essentially a slanted square. Just like a parallelogram is really a slanted rectangle. Okay. All sides are equal. Opposite angles are equal, so it's very similar to the shapes above. This is a little different. Diagonals bisect at a 90. They're perpendicular. perpendicular. I'll make this differentiation, right? Rhombus, different length. Square, same length. That's probably what we should have done up here, right? Parallelogram, different lengths, square, same length. So think about it again. There'll be a long diagonal and there'll be a short diagonal, okay? So again, we can do this, angle, angle, and then this angle goes with that angle. So those are equal. A square has, this is still true that opposites are equal, except for they're all equal. But this is still true, right? Opposite angles are equal. We can make the markings that this line is parallel to that one, and this line is parallel to that one. There. This goes for diagonals here. So first of all, you should recognize this is a rhombus just by looking at this, that all four sides are equal. So it kind of looks like a parallelogram, but it is a rhombus because all four sides are equal. It's a slanted square. And I'm going to use my ruler to draw the diagonal. So this is the long diagonal. This is the short diagonal. And what we know is that they're different in length, but they bisect each other. And not only do they bisect, this is what makes them special, right? They bisect at a 90. They don't just cut each other at an angle like this is 90, like they make a 90. So this is very unique to a rhombus and a square. Okay. I think that's all I have to say about rhombus and squares. Next, we have trapezoids. You have the isosceles, which looks like this. It's your very common trapezoid. That's what you probably think of when you think of trapezoids. And then there's the right trapezoid, which obviously has a right angle here. What do we know about them? They only have one pair of opposite parallel sides. Other pair is equal, or R is equal in length. Base angles are equal. Except right trapezoid. The right trapezoid, you can obviously tell that the base angles would not be the same. So can I ask you to kind of just do like a sub? Well, not really, because never mind. Because the one pair of opposite parallel sides is still the same here. This is unique to this only. Okay, this one is unique to this. So maybe what I will do is, see, my summary makes it maybe even worse. I'll just make another one here. One pair of opposite parallel sides. Two right angles. That's it for the trapezoid. So in terms of my markings, I'm going to just use this one. This angle is going to be equal to this angle over here. So base angles are equal. And this side is the same as this side. That's what makes it isosceles. So it's like almost like a triangle, right? Those two sides are equal. We know that this side is going to be parallel to that side. Same here. This side is parallel to that side. That's about it. And then you have your 90 here, of course. Okay. One more shape is the kite. And then we're done. These are all the quadrilaterals you need to know. Kite looks like this. It's almost like so normally it has a longer base here and a shorter top. Okay. And then we have the markings. So this side is going to be equal to this side. This longer side here is going to be equal to this side. And I'll just tell you something here. Pay very close attention. If these two sides, if all four were to be the same, it would cease to be a kite and you would call it a rhombus. Okay? Because then it would fit the definition of a rhombus where all four sides are the same. So you kind of have to know the similarities, but the differences as well. Okay. This diagonal here meets the long diagonal here at a 90. So that's important to remember that they meet at a 90. only one of them is bisected, so I'm going to use a different color. It's only this one here that is bisected. This one is not bisected. There's a longer stretch and there's a shorter stretch. And there's one pair of opposite angles that is the same. So it's this one here, this one here. Now, I need to tell you another secret with some of these shapes. It works for all of them except for the kite. So grab, I'm going to get a colorful red or blue or something that sticks out. And I will tell you maybe just on this, on the left side, I'm going to go up on the left side here, that these two angles like this always add up to 180. Same with these two, like these two angles always add up to 180. And the same is true for the other side, okay? So think about it, 180 and 180 adds up to 360, right? This one you knew already. If this is 90, this is a 90 here as well. You knew that it was 180, but it's true for all of them. So it's 180 here. This would be 180. Just go up along all those, except it doesn't work for a kite, but it works for all the other ones. 180 here. 180 there. What does that mean? Well, if you have this angle, you can easily find that one, or vice versa. Right? If I give you that this is 50, you know that this is 130. If I give you that this is 60, you know this is 120. Right? Right away, except for the kite. That's the only one that doesn't work for. So this is on video. This is on page 190. Okay, you want to make sure that you have this down and you look at it and you're aware of the properties of the different quadrilaterals, because we're going more sides later. We're doing four-sided, and then we do polygons, which is pentagon, hexagon, heptagon, octagon, all those gons, right? Where has the time gone, right? Hold on. You want to pack already, right? I will do one question, and then I'm done for today, all right? One question. So I'm going to ask you to go to 193. 193. So if you were in class every day and you see some empty pages, that's calculated, okay? I meant for that to happen, because not everything in here is necessarily good. So 193, okay? What page is it on? There it is. Watch what it says. It says find AC. So where's AC? They're asking for this. We're going to put an X there. Find angle A, find angle B, and then what type of quadrilateral is ABCD? So ABCD, right? You go all around. They want you to classify it. Okay? They're basically asking you, what's the name for this shape? And when it's a four-sided, you don't have to worry about the obtuse, acute, all of that. You just have to be able to go to that page 190 and see which one is this. And oftentimes it's very easy. It's very easy to identify. Okay, AC. Well, first of all, you should recognize that this is 60 and this is 60. So if the base angles are the same, then we know that this will be the same as that. So you can just go ahead and say that x is equal to 4 centimeters. That's all you have to do. You just recognize, oh, this is that kind of shape, right? Angle A, how would you find A? Well, what did I just tell you? These two always add up to 180, right? So we'll just go 180 minus 60. Angle A is equal to 120 degrees. So you answered X, or AC, right? This is side AC, which is the same thing as X. We've answered angle A. And B, it's kind of a no-brainer, right? It's going to be the same. Done. What kind of shape is this? It's an isosceles trapezoid. And by the way, you should have recognized this is definitely a trapezoid. So what are your choices for trapezoid? Right or isosceles? That's all you have. There's nothing else that we study. Are there more in real life? Yes. But that's all we study, okay? We're going to pause there and have a great long weekend, okay? And group 4, I see you on Monday, okay? Take care.